We are live. Good evening, dear developers, or good morning. This is international event, and we don't know which part of the world are you watching us from. So this is the power of virtual, remote, online events. My name is Maxim Salnikov. I'm the co-organizer of Angular Oslo Meetup, which is co-organizing this event. This is a super great example of collaboration between Angular Oslo Meetup, Angular Stavanger Meetup, and all Google developer groups meetups around the Norway. So the origin of this stream is Norway, let's say like this, but I believe we have people watching us from all parts of the world, and it's great pleasure to see you, to meet you. We have a really cool program for tonight, and yeah, by the way, this is first experience of Angular Oslo Meetup streaming live, so we keep our fingers crossed for everything goes well. If something, just give us a comment on YouTube chat, so we are watching the comments. 3 sessions today by awesome speakers. All of them are my friends, my old good friends, and I'm super excited to watch these sessions, all around Angular, of course. Manfred, Anna, Fabrice will present really cool stuff. By the end of all sessions, we'll have questions and answers live sessions. So send your, again, questions to the chat on YouTube Live, and we'll pick some questions, and we'll have some form of panel by the end of all sessions. Between the sessions, we'll have really short breaks, maybe 5 minutes, maybe even less, just to do technicalities. And yeah, by the way, I want to say a huge thank you to my dear co-organizers of today's event, my friends Majid and Erwind. Basically, they did all the job on building the program. No more announcements from me. Let's start. And I invite Manfred Steyr from Austria. What are you going to tell us today, Manfred?
Yeah, so thanks for the invitation. I will talk about a possible future of Angular and how these features can influence your architectures in the future. And all this is around Ivy. So let me get started with a question. Did you ever wonder what Ivy does behind the curtains? Because I think we all speak about bundle size improvement and how clever Ivy is, but the big question is, how does this work behind the covers? And let me give you a short answer to that. When we look at this Hello World application here, just a component with a title holding the value Hello World and a template which is data binding to this title, then when Ivy compiles everything, it looks like this at first. It is just an ECMAScript 2015 class, which is produced by TypeScript. Of course, if you down level to ECMAScript 5, it's an ECMAScript 5 equivalent. And then Ivy adds some static properties like this here, this component property, which holds all the metadata you need to execute the component at runtime. If we look into it, we will see, for instance, the type of the component or the selectors or a template function. And perhaps you are wondering why this component or this static property is prefixed with this special character. It looks a bit like a Greek data. Well, the answer is this special character is telling you that this property, also this function here, is part of the private API. So normally you will not touch it by hand. If we look into the template function, we see there everything which was part of your HTML, but now it is down leveled to JavaScript. And this template function takes 2 parameters. The first parameter is a render flag. It can have 2 values. One is telling you that we are in the creation phase, and 2 is telling you that we are in the update phase. In the creation phase, the whole template is created. That means that Angular and Ivy is creating all your tags. In our case, this H1 tag with the title. And in update phase, the data bindings are updated. The second parameter, the context, is just a pointer to your component instance. In our case, the object holding the title property. If we look in there, we see that we first and foremost check for the creation phase. If we are in the creation phase, if the first bit is set, this is here a bitwise operator, then all the tags are created. The H1 tag, also a placeholder within the H1 tag, and the H1 tag is closed. And when we are in the update phase, then we are jumping to the placeholder with the ID 1. If you see here, this placeholder has the ID 1, and then we are interpolating some text into this placeholder, and this text is here just the title of our component, which holds the value hello world. It's really as simple as that. That means at the end of the day, Ivy-based code looks like this. It looks like code you might have written by hand about, let's say, 20 years ago. It is very close to the DOM, and because of this, it does not need a lot of bundle size. Also, we are just using functions here. There are no methods, they are just functions. And functions are really good when it comes to tree shaking. A function can be tree shaked very easily. This is not the case for methods, because we are never really sure if a method is really called or not because of polymorphism, because of late binding. Someone said several years ago that polymorphism is the go-to statement of the 90s, the go-to statement of the object orientation, because of polymorphism, you never know what is really called at runtime. And so hunting down the functions that are not needed is quite easy. Hunting down methods that are not needed is quite difficult. This is the reason why Ivy-based code is really good at tree shaking, and so the bundle sizes are very tiny. But besides this, besides having tiny bundle sizes, the big question is, how does this influence the architectures of our applications in the future? And also, how does this influence future features of Angular? And this brings us to the contents of this presentation. In this presentation, I will talk about several things. First of all, I will talk about lazy components. Then I will talk about dynamic components. This leads to a quite difficult topic, namely higher order components. And then we will talk standalone components. But first of all, let me introduce myself a bit. I'm Manfred. I'm a trainer and consultant for Angular. I'm helping a lot of companies with this topic. And my current product is also about Angular. It's a workshop which deals with Angular for enterprise applications, for big scalable applications. And for this, it contains a lot of advanced stuff you need in such environments. Also, I am part of the Angular community. As you see here, I am a Google developer expert for Angular, and I am a collaborator in the Angular team. Okay, let's get started with the first topic, and with my soulmate. Here you see my soulmate. This all is about lazy components. And as it turns out, lazy loading components in Angular is very easy when we use Ivy. When we use Ivy, just point to the file with your component and then grab out the export that represents your component. Here the export is called dashboard tile component. After this, we need a little detour. We need to fetch the factory for this component for reasons of backwards compatibility. For this, just grab a component factory resolver. Here it's called CFR. You can get hold of it by dependency injection and then use its method results component factory. Pass in the component, you will get back the factory, and then you can instantiate this factory within a view container, which is basically just a placeholder on your page. This view container comes with a method create component, pass the factory, pass the current injector, and yeah, then magically your component is displayed within this placeholder. You even get back a component reference, and you might use this component reference to interact with your component, to set up some event listeners, to set some properties. This view container, by the way, can be fetched by using a view child. You can just use it to point to this or that placeholder element on your page. Okay, that's for theory. Let's have a look into a demonstration I've prepared for you. This demonstration is all about statistics and dashboards. Here in this statistics page, we can add a dial and immediately a dashboard is showing up. And as a matter of fact, this dashboard dial component is lazy loaded. Okay, now you will say, hey, Manfred, everyone can claim that this component is lazy loaded. Please prove it to us. And yes, I will prove it to you. For this, I will reload my page. I will jump into my network tab. I will click add dial. And as you see here, it is really just loaded on demand. The dashboard dial component is just loaded when we need it. Let's have a tiny look into the source code for this. When we look into the source code, we see here our dashboard page component. And this dashboard page component gets hold of the injector as well as of the component factory resolver by using dependency injection. Also, it is taking hold of a view container by using a view child. For this, the view child is pointing to our placeholder. For this, the placeholder needs a template variable, a handle with the name VC. Let's have a short look into our template, dashboard dial, dashboard page component, HTML. Here you see this placeholder. In this case, it is just an ng container with the template variable VC. It could also be each and every other tag, a paragraph, a div, or something like this. It does not matter. Okay, after we fetch this element, we have a reference to it, a view container reference within our property view container. And then we can start with lazy loading. So let's scroll down to our function, which is doing lazy loading. As you see here, it is just loading the component using a dynamic import. We are just using ECMAScript 2017 based dynamic imports. And then we get back the whole file with all its exports. I'm grabbing the export dashboard dial component. I'm grabbing the factory as mentioned before. And then within our view container, the component is instantiated. For this, I'm passing the factory. I'm passing the whole injector. What I'm getting back is the component reference. The component reference points to the component instance, and then I can mess around with my component. As you see here, I'm setting 3 properties, A, B, and C. A, B, and C stands for my 3 colored bars, for the blue one, the green one, and the red one. Also, I'm calling ng on changes. Besides this, of course, I could set up some event handlers for outputs. As you see here, this really works nicely, but perhaps you are wondering, why does this work with Ivy? Because it has never worked before. With ViewEngine, the predecessor of Ivy, this was not possible. Well, the answer is with Ivy, the whole component is self-describing, and this is where the cycle closes to my introduction. When you think back to my introduction, I told you about this component property. And this means that a component has everything it needs to be executed at runtime, because everything is part of those static properties. The Angular team calls this the locality principle. And this was not possible before Ivy, because before Ivy, all this metadata was part of the ng module. And so we needed to load the ng module before we could use the component itself. This has a lot of potential, if you ask me, a lot of potential for future Angular versions, but also for your architecture in the future. One point is, obviously, you can do lazy loading in a very fine-grained manner. You can just load the components on a page when you need it. Perhaps you don't need each and every component. Perhaps it depends on the current user or the customer the application is used for. And if we use this in a very highly way, then we end up with something we might call partial hydration. Partial hydration is just a fancy term for a situation where you just fetch a static HTML site. You just get a static HTML site, which is quite tiny, of course, and because of this fast. And only when you need something on this page, if you click here or there, the components in questions are loaded on demand. This brings a lot of performance, as you can imagine. Okay, this feature is nice, and lazy loading already works today. But now I will show you some additional stuff. And here, one word of caution. The rest of the things I'm presenting to you are using private APIs. And as you know, it is not the best idea to use private APIs in production. So please be careful. Nevertheless, I'm showing you those private APIs for two reasons. The first reason is it makes me feel like an old daredevil if I'm using a private API, and I like it if people say, hey, look at Manfred, this old daredevil. That's the first reason. And the second reason is using these private APIs gives us a feeling with which ideas Ivy has been programmed, with which ideas in the mind Ivy has been implemented. And it also gives us some view to a possible future. Let's start with dynamic components, and this will lead to higher order components. And for this, let's start simple. Let's just imagine a simple function like this, a creation function called create, a factory function, which is just creating a component. In theory, but also in practice, we could create a class within this function. Okay, this looks a bit awkward, but it's totally fine in TypeScript and in JavaScript. Just use a class, and this class will be created once for each call of this function. And then assign some static properties, namely the same properties Ivy would assign during compilation time. First and foremost, we need this component property. And after that, just return your component. Now, if you use this class at runtime, you could use this class as each and every other Ivy-based component. Ivy will treat it in the same way because it has everything an Ivy component has, namely some properties and the static property with all the metadata. As you see here, creating a component dynamically is really easy with Ivy. But now let's go one step further. Let's assume we are also passing another component to this factory function. And then let's assume we are calling this other component within our template function, which is part of the metadata. Then we would have something that's called a higher order component. A higher order component is just a component operating on other components. And for this, I think at least I have prepared a meaningful example that shows all this in action. For this example, let's have a look to my application here. Let me close the other windows. Oh, perhaps I'm keeping this one because this is used for streaming. But let me close Twitter. And now please see that I can pass a parameter here, a parameter called year. When I'm calling it with year 2018, I'm getting a forecast for 2018. I found out by myself that doing forecasts for former years is quite easy. forecasts for the future is difficult, but if it is for the past, then it is really, really easy. So I'm sticking with 2018. As you see here, this parameter is immediately displayed here within the page. And now let's have a look into the source code. If you look into the source code, you will see I'm just using an input here. And this works, at least in my implementation. Normally, that does not work. Normally, we needed to get hold of the current activated route. And then we needed to talk with this activated route to fetch all the parameters and to pass all the parameters to the respective properties, like year in this case. But here, my component is router agnostic. It does not know about the router. It only knows about the inputs. So the big question is, how is this possible? Well, if we did not use Ivy, if we did not use higher order components, we needed a wrapper component. A wrapper component like my component routed here. It's just called the routed component. And as you see here, this routed component is getting the activated route by dependency injection. It is subscribing for all the routing parameters, and then all those parameters are passed to a property called params. And if we look to the routed component HTML, you see I'm just calling my inner component, my real component, my dashboard page component, and I'm passing all the routing parameters to it. And if you think about this, this of course works, but if we need this in several places for several components, we had to duplicate this very component and just to exchange the name of the inner component and the name of all the parameters. And of course, that's annoying. And so I wrote a higher order component which is automating this, which is doing something like this in a dynamic way. Let's have a look at our app routes configuration file. As you see here, my app routes are just pointing to my dashboard page component. And this dashboard page component is wrapped into a call of my function with route. And with route is exactly doing what I told you. It is creating a dynamic component, and this component is talking to the router and passing everything to the dashboard page component. Let's have a look to it. It's a bit ugly because it's meta programming and very generic for this reason, but let me show it you so that you get the basic idea. I'm passing in the inner component, which is the wrapped dashboard page component or some other component, and then I'm messing around with this component. I'm grabbing the component metadata, and this component metadata has a selectors array somewhere. And this selectors array holds the name of the selector, which is here in this simple example, just dashboard page, the name of the tag. Then I'm creating a class. The class has everything we've discussed before. And then I'm assigning all the parameters, first and foremost, this component metadata parameter. The component metadata parameter is pointing to my inner component, to my dashboard page component, so I'm capable of using it. And my template function looks if we are integration phase, and integration phase, an element is just created within my template. Of course, the element name is in our case dashboard page. In the update phase, I'm just iterating through all my routing parameters, and then I'm assigning all the routing parameters to the respective inputs, to the properties with the same name. This happens here. This property function is just doing property binding, as you can imagine, and that's all. At the end, my higher order component is returned. Perhaps you are saying now, boy, this is really difficult. Yeah, it's difficult because it's meta programming, but I think at the end of the day, you will just hide it behind convenience function like this. And of course, you will not write code like this on a daily basis. but I'm really sure that a lot of people will create nice libraries which will extend the possibilities of Angular with such tricks. So hopefully we will be more of a consumer of such functions than the producer. And this is the potential. We have a lot more dynamic, and this is the basis for a lot of framework extensions which will show up in the next time. Now let's come to my favorite topic. This topic is about standalone components, and I'm really looking forward to it. You could put it in another way. You could say, well, a standalone component is a component which is not needing ng modules. And saying this, ng modules will not go away because that would be a breaking change. But the Angular team is investigating ways to make them optional because they have never been a child of wish. They have been needed but not wanted. And so let's have a look how this could look like. The first question that arises when using components without ng modules is, how does the outer component know which inner components it is allowed to use? In our case, the question would be, how does the dashboard tile component know that it can use the bar component 3 times? Once for the blue, once for the green, once for the red component. Because this is something the ng module provides for us. Well, it turns out that the component metadata contains all this information, the information about the component's neighborhood, as I call it. In our case, it has a directive defs array. It could also be a function returning an array, and this array consists of all the other components we can call. In this case, the bar component is part of the neighborhood of the dashboard tile component, and that means the dashboard tile component is allowed of calling it. And honestly, at runtime, this is everything an Ivy component knows. That means already today, Ivy does not care about your ng modules at runtime. At compile time, for reasons of backwards compatibility, the Ivy compiler is just transferring the data within your ng modules to this very representation, to a representation where everything is part of the directive defs. Of course, if you would use something like this, you needed some type assertions to make it work, because we all know TypeScript is statically typed, so you need to cast back and forth. I just skip this for the sake of simplicity. But it's really not more like this. And in theory, when you used private APIs, you could already use this mechanism today at compile time. Of course, no one prevents you from grouping components that are used together. Perhaps the bar component is used together with 5 other components most of the time. And in this case, it would be a good idea to just put it into an array. And if you think about this array is pretty much what the export section of the ng module is today. Just a group of things that you want to export together. And if you use an index.ts in addition, which is just an public API for a part of your application, for instance, for a library of your application, then you have really a proper replacement for ng modules. And the best thing, this replacement is not using Angular features at all. This is just pure ECMAScript. If you ask me, it's always a good idea to exchange a framework feature by a platform feature, because the platform feature is more explaining itself, and it is also easier to use. You don't need stuff from the framework. It's more self-explaining. I think that was the term I searched for. Okay, now you will say, of course, that works in theory, perhaps it also works in the future in practice, but somehow it's annoying if we have to define the neighborhood of our component in an imperative way, because Angular and all the other frameworks are about defining components in a declarative way. And so it's good to hear that Minko Getchev, who is part of the Angular team, did an experiment. He took Angular about 1.5 years ago and he forked Angular. And then he introduced this tiny experiment we see here, namely a dependencies array, which is part of your component decorator. And there you can now put in all your components. For instance, a component array or just a component you want to use within your, let's say, dashboard tile component. Saying this is just an experiment, but it shows that the Angular team is investigating ways for making ng modules optional. We don't know if this feature will ever land or if a similar feature will land in Angular that makes this possible. Okay, let me show you a simple example for all this. In this case, I'm using one more time my bar components as part of my dashboard tile component. And if we look for this into our source code, into the dashboard tile module, we see that before, obviously, the bar component was registered alongside the dashboard tile component. This really worked before. But now this is not the case anymore, and even though it works. So perhaps you are wondering why is that? And the answer is, I wrote this component dependencies decorator just for the sake of demonstration. Please don't do this at home, but here just to prove that it would be possible, I wrote it. And this is just doing what I explained before. It is taking all the components within this array and it is putting it into the directive steps array of this very dashboard tile component. And so I can really use it without using ng modules, as you have seen before. So at the end of the day, what happens here is just what Minko did in his experiment, but without the need to fork Angular. I really hope that something like this will land sooner or later in Angular itself. Okay, nice feature. By the way, with Ivy, you can also bootstrap standalone components. For this, just use this render component function. As you see by the prefix, it is still private. It has this theta, but in the future, hopefully it will become public. In this case, just pass your component and then Ivy will display this component on your page. This has a lot of potential. First and foremost, your project structure will become clearer because you don't need ng modules anymore. You just have libraries and or barrows with an index.ts. And this index.ts is just exporting everything you want to export from a specific part of your application. This makes it more self-explaining, and this also makes Angular more easy to learn. As a trainer, I've seen that learning ng modules is somehow difficult for people that are new to Angular. They are wondering, why do I need it? Because we already have TypeScript imports. Why do we need Angular imports and Angular modules? And the second potential here is this is really a big deal for web components. Because web components, if you ask me, are just standalone components. They work in a standalone mode. And if you want, you can bring them to work together. You can make them to work together with other components. But first and foremost, they also work in standalone mode. Let me come to a bonus chapter I've prepared for you. I think I have some time to talk about this. This is about another nice feature Ivy will enable, namely zoneless change detection. Perhaps you've heard about Zone.js. And even though you did not hear about it, you're using it all the time because Zone.js is the key to automatic change detection Angular. What does it do? It does something that's somehow a bit, let's call it special. It monkey batches all your browser objects. That means when your application starts, it goes through all the browser objects and just batches them. It is assigning some event handlers to them so that it can find out when something changed. It can find out if an event handler run, for instance. And every time an event handler run, it tells Angular, hey, Angular, there was an event handler. And so Angular knows, okay, I have to update all the data bindings because in theory, each and every event handler can update all the properties that are data bound. And so this is the key for automatic change detection. This works quite nicely, but it has some downsides. One downside is it has 100K. And normally this is not a big deal, especially for business applications. It's not a big deal. But for web applications, no, for web components, I wanted to say, for web components it is. Because when you have a web component which has, let's say, 10Ks, it's somehow ugly to ship it together with Zone.js, which has 100Ks. No one will buy this. And another downside is monkey batching is somehow magic. Changing pre-existing browser objects like all the DOM object, the promise object is somehow a bit special and magic. And a member of the Angular team said once ago, it really works nicely until it stops working. And when it stops working, you really have a hard time finding out what happens. You really have a hard time hunting down this bug. There is another downside, which is everything but not obvious. Namely, you cannot monkey batch native async and await statements because you cannot monkey batch keywords at all. Normally, we don't recognize this nowadays because normally we down level our code to ECMAScript 2015 or even to ECMAScript 5. And when you do this, async and await is down leveled to promises. And of course, we can monkey batch promises because promises are just objects. But if we down level to ECMAScript 2017, this would not work anymore because then we would get these very statements as part of our bundles. And as mentioned before, we cannot monkey batch statements. If you don't believe me, just set your target, your compilation target in your dsconfig to ECMAScript 2017. First of all, because it is nice, the CLI will warn you. The CLI will say, hey, what are you doing there? It might stop working. Your application might stop working if you do this. And then at runtime, you will run into issues with data binding when you use async and await. It's a nice experiment. Don't do it within production. And if you do it within production, I have one hint for you. Activate it, go on a business journey. Nothing will work anymore. Come back, change it back to ECMAScript 2015, and then you can say, look, people, without me, nothing works here in this company. Your colleagues will really love you, I guess, or perhaps not. I don't know. Okay. So the good message here is Ivy does not care about Ivy. Everything Ivy cares about is that someone is calling Mark30 or some similar function when something is changed within your component. This is everything Ivy wants from you. Currently, for the sake of backwards compatibility, Zone.js is still used to call this method, to call this function. But in future, you could exchange Zone.js by another mechanism, which is triggering Mark30, or you could do it by yourself. And let me show you a simple example for this. In this simple example, I will deactivate Zone.js by using the noob zone. By the way, this works since Angular 5. Since Angular 5, you can tell Angular, don't use Zone.js, just use this no operation implementation of Zone.js, which is basically doing nothing. Nulla, niente, nothing, null. So normally we don't do this because normally this means we have to do change detection manually. But this is exactly what I want to show you in this experiment. Zone.js is not here anymore. So some parts of my code behave a bit ugly. But when I'm clicking here on more, you see change detection really works. And this only works for one reason, namely currently I'm calling Mark30 by hand. Let's have a look into my dashboard tile component. Here you see, after changing everything, I'm calling it by hand. So in theory, it really works without ng zones, but in practice, we want to have automatic change detection back, don't we? Because we use frameworks like Angular because of this feature. I think this is the most obvious feature why we want to have something like Angular. And so people are investigating ways to bring back this automatic behavior. And there are some ideas. For instance, if you look in the newest version of NGRX, you will find the new package, which is called NGRX component. Currently, it's quite a tiny package. It only consists of one pipe and one, I think it's a directive. Yeah, it's a structural directive. And the pipe is called NGRX push. This push pipe is just doing what async is doing. It is a drop-in replacement for async. But besides what async is doing, it's also calling Mark30. And it does not need Zone.js for this. That means if you go reactive, if you go with observables, just change to NGRX push and you are on the safe side. It will work without Zone.js. The funny thing is, this idea has been around for 3 years, I guess. I've seen the first prototype for this from an Angular team member about 3 years ago, and now it's production ready, and it's there as part of NGRX. This is one idea. Another idea is this one here. It was presented by Mike Ryan, who is also a team member of the NGRX team, and it's about this connect method. It will be hopefully also be a part of NGRX component in the future. As you see here, we can pass an object with some observables to connect. And now connect will do several things for you. First of all, it subscribes to all those observables. And every time the observable emits a value, it puts this value into our state object. In my case, I can use it with state.data. And also, it every time calls Mark30 when we get a new value. And so this is also a nice way to work without zones. The Angular team is also investigating some ways to work without zones, even if you don't have observables. One way could be to teach the compiler new tricks, to tell the compiler to introduce calls to Mark30 when needed. And another idea is we could introduce something we have in React, a method called setProps, set properties, to update the properties of our objects, of our components. Those are just rumors. We will see with which ideas the Angular team, but also the community, especially the NGRX team, will come up with. If you like this talk, I want to encourage you to look up my blog. I have a lot of blog articles which deal with all this stuff, with ideas how we can improve our architectures and our applications in the future. So if you like it, look it up. If you don't like my talk, please look up my articles anyway. Perhaps I'm writing better than I'm speaking, who knows? So let me come to a conclusion. We have seen several things. We've seen that we can do lazy loading in a very fine-grained manner with Angular. This brings a lot of flexibility and ends with partial hydration, where we just load a static page and everything we need is just loaded on demand. Brings a lot of performance, obviously. We've seen we can use dynamic components and higher order components to make everything a bit more dynamic and to provide framework extensions like my extension, which allows a component to read data from the router without knowing the router. And standalone components help us to substructure our application just with barrels, with folders, and with libraries. We don't need ng modules anymore. We just have, let's say, a barrel and index.ts exporting everything this part of the application wants to export for other parts. And saying this, standalone components are also a big deal for web components. And I want to close with a side from my most favorite scientist. I really like him since I'm a child, namely Emmett Brown, PhD. Perhaps you know Emmett Brown, PhD. He is a very clever guy. He is inventing time machines and something like this. And at the end of Back to the Future 3, he said this sentence. He said, "Your future hasn't been written yet." And I think what Emmett wanted to tell us is we don't know how all these features of Ivy will affect Angular in the future, because the future hasn't been written yet. But we know it will somehow affect Angular, because Ivy has been written with all these ideas in mind, So please stay tuned to find out how future versions of Angular will just use those features as part of its public API. I'm pretty sure that was what Emmett had in mind back then. Okay, that's all from me. Here you have my contact data. You find my slides and all these examples in my blog. And if you want, follow me on Twitter so that we can stay a bit in contact. Thanks for having me and enjoy the rest of the meetup.
Thank you very much, Manfred. It was awesome. So, as always, unexpected. And thanks everyone for watching us right now. We got actually one question for you, Manfred, but we will answer this question at the end of the whole talk. So please stay with us. Manfred will be here. So, and then we will raise a question to Manfred and he will answer your question. So we will go for a breakout, maybe less than 5 minutes, and then we will be back by Anna for the next talk. Thank you very much. Stay tuned. Hi everyone, we are back and we have Anna with us right now. Anna is a developer advocate at Auth0, so she's very well known actually in the community. I bet all of you probably know her. So she's going to talk about Angular element in for authentication, and that would be awesome. So please welcome Anna. Anna, here we go.
Thank you, Majid. It's a real pleasure being here today, and thank you for having me. I wish I was actually in Oslo, but I guess one day we'll make that happen. So let's get started. Angular elements for authentication, the what, the how, and the why. For those of you who don't know me, like Majid said, I'm a developer advocate engineer at Auth0. So Auth0 is a flexible drop-in solution to add authentication and authorization services to your applications. So if you have any questions on that or on this talk, feel free to always reach out to me on Twitter. You can see my Twitter handle just there. It's at @anasidri_. Apart from my day-to-day work, I'm also very involved with the community. I'm the organizer of NG Spain, which is an Angular conference in Spain, which for obvious reasons isn't happening this year, but hopefully next year I'll get to meet some of you there. And I'm also the organizer of Girls Tech, and I'm a Women Tech Makers ambassador. And they are both initiatives to help and promote women in tech, which is something I'm pretty passionate about. Okay, so let's get started. And I think the best place to start is by figuring out what a web component is. So a web component is a component that is completely platform agnostic, which means that we can reuse them as much as we like, and we also gain maximum interoperability. Also, these web components can be encapsulated however we like. So that way we don't prevent any, styling or behavioral leakages in or out. When we tend to think about or talk about web components, we tend to think that they are dumb components. However, this is not true. They can also be smart components, and we will see that in just a bit. So what do these web components consist of? Well, they consist of three main technologies. The first one is HTML template, which is basically a HTML tag called template, which is where we put our template of the element in. Then we have custom element, and this is going to allow us to create a HTML tag, extend or improve an existing one. Now, when we do create a HTML tag, we have to be careful with the naming, because we need to remember to add a dash in there so that the browser knows it's a web component, but also to follow best practices, make sure that you name the component in a way that others and your future self will understand what it is. And last but not least, and certainly not the least important, is Shadow DOM. So Shadow DOM is what allows us to have that encapsulation that I was just talking about. So to get you started, what we're going to do is create a DOM component. And what it's going to be is a simple login button. Like I said, it's a DOM component, so it's not really going to do anything. But we're going to be able to style it from the style attribute. So first of all, we're going to do the template. And all we have is a simple button with an ID of login button. The styling we'll get to in just a bit because it is an important part, but we'll get to that in just a second. So the custom element. First of all, what we're going to do is call the class, and it's going to be called login button element, and it's extended from the HTML element. And this is so it can be recognized as a DOM element, but also we can actually inherit all of the features from HTML element. Then we're calling the constructor, and inside there we have super, so we have access to all of those APIs. Now, here's where we would add the Shadow DOM. And to do so, it's just two simple lines of code. And what we're doing is we're passing the mode open to attach shadow. So we're doing this so that we're asking to create an open Shadow DOM. And why would we do that? So what we're doing here is we're giving developers a possibility to manipulate the structure of your component via JavaScript. Now, if you don't want this, you can always close it. However, I would generally advise to keep it open because you never know how other developers are going to use your component. So say, for example, an example I like to give is an image gallery that on a web app, it's a simple image gallery. But if we take it native, then it might turn into a page that you scroll across, right? So you never know how others are going to use the component that you created. And then the second line, we're just cloning our template, and instead of adding it to the DOM, we're adding it to the shadow DOM. And last but not least, we have to define the custom element. And to do so, we just give it a name. Like I said, be cautious about how you name your web components. And then we pass in the property. So remember how I said when creating the template, we had to think about styling? Now, this is very important, and sometimes we forget about this because people are going to use that web component in their own environment, so in their own application, and they might need to change the design because of corporate identity reasons or because of personal preferences, whatever it is. They're probably not going to want the same styling as you. So there are two ways to go about this. And the first way is through CSS custom properties. And I would recommend this way mainly because the browser is more stable. It almost fully supports it. Obviously, Internet Explorer, I'm not going to go there, but yes. And how do we implement this? Okay, so in our template, in the styling, what we need to do is call CSS variables. And when you call a CSS variable, what you need to do is call on the property of your choice, for example, background color, you call var, you open the parentheses, you put the variable name that you give it. It has to start with a dash dash because it's a CSS variable. And then you give it a default, in this case, color, default value, and that's the fallback option. So how would the external developer then use this? So what they would do is in the HTML login button on the styling attribute, they would just add that variable name that you gave it. So in this case, dash dash background dash color, and add the color. In this case, color, it might be font family, it might be font size, any of the properties you can add a variable to. So this gives you a good idea of how this could be used. And then what we have here is the CSS shadow parts. So this is a really cool feature. It's a pseudo class. And if you want to go more in depth about this, I really recommend that you read this article that I put there in the source by Monica, because she goes pretty much in depth. The only problem with the part pseudo class is that browsers aren't fully stable, but I know that Safari is working on it. So hopefully that will be a good big improvement soon. Now, what's so cool about this? So the web component we're currently constructing is a simple button, but imagine you have something a bit more complex like a form, or it might be a card, or just anything a bit more complex that has more than one part to it. You might want to allow developers to change only certain parts of that part, right? So you might want them to be able to style, maybe in this case, you can see it, a div or an input. However, there might be another div that you just don't want them to style for whatever reason. Well, to do so, what you do is the parts that you want them to be able to style, you put the part attribute and you give it a name. And then, and then what they do is in their style sheet, they call the web component, then they call the part pseudo class, and then inside the part pseudo class, they put the name of the part there. And then they can change all the properties that they need to. So how would we implement this into our button? Because we can still do that, even though it doesn't have much to it. So again, we call the part attribute and we give it a name, which in this case was custom button. And then the user would, in their style sheet, or for the simplicity of this talk, I just put it in the index.html, they call the login button, the part pseudo class, the name of the part, and then the properties that they would like to change. And that's basically it. So we basically just very quickly covered how to create a very simple web component. And then on this web component, people can add whatever attributes they want to and do whatever they like. Now, let's take this a step further because we are in NG Oslo. So let's see how we would do this with Angular. Well, the Angular ecosystem does provide Angular elements, which allows us to do exactly this. So let's see how we would do this. First of all, I assume you already have Angular installed, but just in case you don't, you need to install Angular. You need to create a project, which in this case is going to be called login-button-angular. And then you go into the project, you add Angular elements, and then you install the polyfills. Once you've installed the polyfills, you go inside your polyfill.ts file and you import them. Right, and now what you need to do is in the tsconfig.json, you need to change your target to ES 2015, basically because browsers that support custom elements natively, they require developers to do this. And we're going to generate our component. Now, the component we generate is a simple Angular component, nothing funky or fancy going on yet. We'll see that in just a second. And then what we do here is we're going to add these 3 technologies. So starting with HTML template, we're just having our template. We added a bit of interpolation there to do something. And that will then be binded into the input property here. And then what we need to do is the second part, which is adding shadow DOM. And what we do is we set encapsulation here to the view encapsulation.shadow DOM so that we have that encapsulation that I talked about previously, and we won't have any styling or behavioral leakages in or out. And the CSS, I basically copied and pasted from our previous component. We have the variables like we saw before. And last but not least, and probably the more complex part, we need to define our custom element. So what we need to do here is we need to declare and put that component into the entry components. And this is necessary because Angular Elements is creating it dynamically at runtime. And then we have the create custom element method so that it basically looks like a web component. And then we're using the custom elements.define, which is what we saw previously. And this way we can register it to the browser. And we're basically done. It's all fancy, right? Well, not quite, because the build in Angular isn't great for when it comes to web components and Angular elements, because what it does is it still has a huge bundle size, even with Ivy. Yes, there is. We saw what Ivy has, thanks to Mangular, Manfred. Mangula. I'm going to call you Mangula from now on, Manfred. And there isn't support for one bundle. If you want to reduce that, we could eject Webpack or hack into it and do some crazy stuff there. And it's possible, but it's all very complicated. But thanks to Manfred, who we just saw, we do have this amazing NGX build plus. So this basically extends the CLI. We don't have to do any ejecting. We can build a single bundle, and there's no need to add Angular with an Angular to make the project even bigger and make things all crazy. And it's pretty simple to use, actually. I'm actually going to quickly show you how we can use the NGX build plus for Angular elements. First of all, what we need to do is add it. And then we need to make sure that it's actually added to the builder. We then create our file, in this case called webpack.extra.js. And here what we're putting is everything that we want to remove from our application. And then when we build it, when we do the build, we just need to say that we want one bundle and not 2. So that's pretty much it. And now our component is ready. But wait. Up until now, we've seen how to create a web component and an Angular element, but this title says that it's Angular elements for authentication. So what is authentication? Authentication is the process of confirming an identity. What do I mean by this? So basically, it's when a user and applications prove who they say they are by providing valid credentials. Now, these credentials might be a username and password, and they're normally, or they should be, combined with other elements. And these elements are factors, which tend to fall into 3 categories, right? So it's either what you know, what you have, or what you are. And we call this multi-factor authentication. And we do try to say that this is the best way of doing things to keep your application more secure. So what about authorization? Now, authentication and authorization tend to be used interchangeably. And even though they do go hand in hand, they are not the same thing. So whereas authentication is the process of confirming an identity, authorization is a process of verifying what a user has access to. So once the user is authenticated, so once it's granted access to an API, that API then determines the extent of the permissions it should assign. So it's this next step. And even though access to a resource is protected by both authentication and authorization, in this talk, we're just going to be talking about authentication. So how can web components help when approaching authentication? Now, I'm going to talk about authentication. However, web components can help in many ecosystems in the same matter. So the first one is maximum interoperability. Now, this isn't just tied down to authentication, but I'm going to give you an example within authentication. Now, say that you're in an enterprise company that has several products, several product teams. Each team has their own framework that they're using. So you might have one that uses Angular, one that uses Vue, and one that uses Polymer. And they're all building the same product, which might be, and they need a login for this service or product or whatever it is. And so if we had them using 3 frameworks, then they would have to create this login process 3 times, but they'll need the same UX experience, or they might not need the same design, but they'll need the same feel that it belongs to the same company. And this would cause 3 times the headaches, 3 times the bugs, 3 times the sleepless nights. Now, if you were to create a web component, well, you could just create it once and then it would be used across the teams. So that's what I mean by maximum interoperability. Now, if you want to know if your framework is web component friendly, then you can check out this website by Rob Dodson. It's a really cool website. Next, they're very, very easy to implement. And if they're not, then they've not been done right, basically. So where we have SDKs, which tend to be already a step forward, a lot easier to integrate than building something by yourself. That's step 1. The next step, I would say, in my opinion, would be a web component, because all you need to do is put in this HTML code, fill out the attributes, and if you need to do anything funky, well, you can always do that, but it's not necessarily. But don't forget to do an npm install, obviously. But that's basically it, and it won't take you weeks like building it from scratch would. Next thing is that they're very, very flexible. So one of the things that allow us to have that flexibility is we can choose what HTML attributes we want to add there. We build the thing, so we can do whatever we like there. And like we saw before, styling. So we allow outside users to style them however we want. And there are 2 options to do this. So that's pretty cool. And continuing with flexibility, we have slots. So slots act like a placeholder where we can allow the user or developer to either add that part of code or not. Now, say, for example, I had a login and a logout button, and then I wanted to add a description next to it. But I know that maybe not all developers want this. Well, I can just make that a slot. And what you should remember, and best practice, is to always give your slot a name, even if you have just one, because in the future you might decide to add another one or whatever, and then the browser needs to know which slot to render. Then the developer can decide whether they want to use the slot or not. And if they want to, they might have a div where they call slot, they put the slot name, and then they add whatever they need to there. Right, so what web components could we actually create to make authentication more simple? So one of them might be a simple login screen where you have login buttons and social buttons. The next one might be a web component that shows when the user's logged in, it might show their name, or when you click on their image, it might show their profile, or it might do roles. Many options there. But the one we're going to concentrate on today is a login button that uses Auth0 to deal with the authentication process. And that way you don't have to deal with SDKs. So remember that DOM component that we created? Well, we're going to make it smart. And to do so, we are going to use the Auth0 SDK. So we just need to do an npm install of that. And then we're going to generate the service. And we're going to copy and paste from the SDK the service, because we like to copy and paste. But if you see something here, what we want to create is a login button where we can change the domain and client ID from the outside. So it's no good to hard code this. So what we need to do here, or what I did here, is create an interface. In this case, it's called credentials with the domain and client ID of type string, because that's what it needs to be. And then where it's hard coded, we replace it. And then our HTML changes from being a simple button to this. So it shows whether the person's logged in or not. It shows the corresponding button. And this is also from the SDK, and it's calling these login and logout methods from the Auth0 client. And then what we have here is the auth, we're calling the auth service in the constructor. We have the inputs there of the domain and client ID, which we use in the ng-on-it, which is invoked when the component has been initialized. And then we have the ng-on-change, because what we want is the latest version of the service. So this happens, this is being invoked every time there's a change in one of the input properties, so either on the domain or client ID, and that's why we need this here. And then what we have is our web component with the domain and the client ID, which we can add from the outside. You get those values on your Auth0 dashboard, and then you just style it however you like. So this would basically be the result. And when you would click on the button, it would take you to your customized dashboard, and then you would see a logout button in case you wanted to log out. Now, if you want to take a deeper look into this code, feel free to. It's on my GitHub here. And yeah, so we just made a DOM component smart. Pretty simple, huh? So now that we have a web component, say we want to add this one that was maybe created instead of, let's just say for the sake of this talk, that it wasn't created with Angular, that it was created with a different framework or with something completely different, and we want to add it to our Angular project. What we need to do is install the polyfills, import them into our polyfill.ts file, create the schemas array and call custom element schema so that Angular knows that it's not an Angular component but a web component. And then in our component, we just import it from whatever folder we put it in. And we use it. So it's a 4-step process and it's pretty simple. So I've mentioned that we can use Angular to create it, but I've also mentioned that the build isn't great. We do have a solution thanks to Manfred. However, there are many other libraries and frameworks out there that allow us to create them, and libraries that are actually built just to create web components, and which we can then implement very easily, as you saw, into our Angular project. There's Hybrid, there's Slim, there's Skate, there's Lit Element, which is actually my personal favorite, but again, it's a personal preference, just like you all probably prefer Angular because that's why you're here. It's just a personal preference. It's nothing, not because the others aren't as great or anything like that. So what I encourage you to do is actually try some of these out and figure out what you like, and then you can build web components and integrate them into your Angular projects and share them across your teams. So it's pretty cool. Now, I know when web components first came out, there were a lot of issues. Polyfills weren't great. The browsers were not ready. So people very quickly decided that web components weren't for them. Now, I have news, good news. The browser is fully stable, so we can use them. There's no more excuses, and they work really great. And there's even really, really good polyfills for whatever other browsers there might not be supporting them. So I would just like to thank you all for having me and listening to me. You feel free to send me any questions on Twitter. I'm not sure if I'll be around right at the end because I have to put the kids to bed. But if not, Majid, I assume, will send me the questions and I will answer them as soon as I can. So thank you.
Thank you very much, Anna. It was awesome, great as always. So we got a question for you since you're leaving us. Maybe I can quickly ask you right now because I think that the answer would be very short. Someone asked that I saw that the component was added to entry components. Is this needed with Ivy? I'm not sure exactly when he asked this question, but that was the question. Maybe you know.
Yes. I think actually we still need to do this with Ivy, but I also think that Manfred would know more about this?
Yes. Okay. Then in our end of the sessions, I will ask also from Manfred. Maybe he can elaborate on that. Thank you very much, Anna, and have a good day today. And thank you everyone for watching us again. So we will be back in maybe 2-3 minutes. Stay tuned.
Hello, guys. My name is Fabrice Simoni. I'm streaming in from the west coast of Norway, Stavanger. And today I'm going to be presenting how to enable strict settings for Angular and TypeScript projects in order to increase developer productivity by discovering errors earlier. I work for a local consultancy called K30.no. I just had to plug that in there. My Twitter is @SFabrice if you need to reach me. And the demo is going to be available on the link below. All right, let's go. So in a typical Angular application, you have these two sections of the tsconfig file. You have the compiler options, which dictate the options that are going to be used to compile your application. And you have the Angular compiler options, which is used for Angular compiler. And for us, what's relevant is the strict templates flag, which is a new flag that's used to actually type check your templates. So let's go deeper into the TypeScript side. So with TypeScript, you can set the strict true flag, which is going to enable all these flags below here. Set them to true. We're going to go through them individually to see what they do. So let's start with no implicit any. So I'd like you to take a few seconds to look through the code above and tell me what the template is going to print. Sum. All right. If I click it, you see that we get 13. If you look at through the code, assuming that this is pretty contrived example, but in your day-to-day work, you're working on medium and large applications, so things like this might go through. So you might just skim through the code and be like, oh, add 1 plus 3, expect the value to be 4. So when would you typically catch this? If you're kind of detail-oriented, you could probably see that the error is that the value is a string, while the signature of the function add expects numbers. But usually, because there's a lot going on, you have to wait until running the application to actually find this error without this flag set on. And when we turn this flag on, this is what we see below. I hope everybody can see my screen. So specifically, we are looking at the this.sum is equals this.add 1, right. The right there is underlined, indicating that the type is wrong. So this is expecting a number, but it's receiving a string. Next up, no implicit this. I don't have the code for that. I'll get back to that. Always strict. This is strictly about what's emitted in the final JavaScript files. When you compile the TypeScript files and emit to JavaScript, it's going to add a useStrict statement on top of the emitted code. And what this does just changes the semantics of JavaScript to be more stricter and catch more errors. So usually this is not something we have to worry about. Strict bind call, again, same example. Read through a bit and see if you can spot what's wrong here. What do you expect to be printed? Okay. Again, we are seeing 12 is printed here. Again, if you look at the definition of the function, it's expecting to add 2 numbers. And as we can see from earlier, these are strings. With enabling this flag, the compiler can tell that this function is being called with the wrong types. And you end up with the 1 and 2 underlined here, telling you that those are the wrong type. Strict null checks. Same idea. What's different if you look at the right argument here is optional. What would you expect this to be printed? We get a none, not a number. And if you've seen it, the reason is that we are trying to add a number to undefined, which returns not a number. Why is this happening? Why is it able to? This is one of the kind of when you first turn off the strict setting. This is one that's gonna light up a bit if you are not, if you haven't been diligent with this type of code. And the reason is that this is possibly undefined, so you need to check for it before for you to get the right behavior. And with the flag turned on, this right variable here is gonna light up, telling you there's something wrong there. Strict function types. This is one of the weird ones when I first tried to turn the settings on a larger project, because right now we have a custom validator function, and without this flag on, everything looks fine and works fine. But as soon as you turn this flag on, then you get an error telling you that something is wrong. And what this turns out to be is that before this was introduced in TypeScript, the arguments of the function used to be something called in CS terms a bivariant. That means given a type as an argument, you can pass in a super type or a subtype. Basically, both cases are allowed, which intuitively seems unsound. And what they changed was make the arguments of a function contravariant, meaning that it can only take its type and its super type, and that's it. And if you look at this case, form here is a form control, which is a subtype of abstract control. But because becomes contravariant, which means it accepts a super type, it doesn't allow this to happen. So usual fix for this is just changing this to match the super type, which is an abstract control. And in my case, that's going to work fine because I'm not using anything that's not available in a parent type. And then at the end, we have strict property initialization. And look through the code a bit. See if you can spot what the problem is and what the output is going to be. All right. If I click it again, we get not a number. This is a little bit similar to the previous case, where we are using this.default +1, but this.default is not defined. It doesn't have a value. It's just declared without a value. So you get undefined and you get a none. And then with TypeScript, with this flag, we can prevent these cases from happening because you are required to initialize a declaration. But there are some cases where the initialization is happening somewhere else. Either you're loading a library globally or something like that. And in this case, you can use exclamation point in front of a variable to tell the compiler that I know that this variable is initialized. In that case, you don't get an error. And if we look here below, default value is underlined while initialized somewhere else is not, because we are telling the compiler to ignore this case. All right. The no implicit this case, for some reason, I must have messed up the coding, but this is a case where you are using this variable in a context where it's not available. When at the end, I'm going to go through some code and we're going to see in this what happens. Without this on, you won't know that you're doing the wrong thing. But as soon as you turn this on, TypeScript is going to tell you you're using this the wrong way. All right, let's go on to the Angular side of things. All right, so with Angular, we got some new flags to check the template. The first one is the strict input types. Okay, let's look through this code. We have the TypeScript, we have an interface square, which have X, Y of type number. And we are creating a child component here, which takes a square as an input. Then on the HTML side, or template side, we are passing in the square with just an object missing the Y property. Now, without this check on, everything works fine. Obviously, something is wrong because the child component is expecting the square to have X and Y. So you might use it in the child component and expecting it to be there, but there's nothing telling you that it's not there. So until you run this, you won't know. Again, that's going to slow down your productivity. When you turn on this flag, this what's the error you're going to get from the compiler. It's going to tell you that property Y is missing in type X number, but required in the square. So it's basically looking at the type of the input and inferring the type and checking if the type passed in matches. Next up, strict null input type. So this one is a little bit special because it actually works in together with the strict null on the TypeScript side. So you have to turn on that strict null checks in TypeScript side for this to work. And how is this manifested? Again, if we look at through the code, it's a little bit similar to the previous one. So in this case, we actually have two components in the TypeScript side. So we have the previous child component, and then we have a component that's using the child component. And it has this strict null input types component has a local variable property, my square, which is of type square or null. And then even you probably know where this is going. We are passing my square to the square property of child, the child component, which doesn't match because we are passing in a null. But the child component with strict null checks, you can't pass a null if you haven't strictly said that we allow nulls to be passed in. So what happens in this case when we turn on the flag? The compiler is gonna tell you type square or null is not assignable to type square, as expected. Next up, strict attribute types. This one is a little bit interesting in that it only checks if we're using a text attribute. So if you notice in earlier examples, we had square brackets around square in the template, indicating that we are getting we're expecting an expression on the right side. But right now we're just using a text attribute, which means this value on the right side is actually going to be processed, or the value on the right side is going to be a string and not an object. It's not an expression. So what error does this create? This says type string is not assignable to type square. Again, without this flag, this is not going to be checked because it's not going to be checked. Next up, strict safe navigation types. Okay, so the safe navigation operator is the one where if you have an object and you are accessing values, properties on the object, you can say only do this operation if the left-hand side is defined. And what would you expect the type of X in this case to be by default? For those who haven't figured out, the answer is any. So even though X in this case, if you look on the TypeScript side, is a number and it can be inferred on the TypeScript side, as soon as you use the safe navigation type, X becomes any. And if you look at the print method here, it's taking a string and printing a value. There's going to be a problem because, well, it's not a problem in the default case because it's not any matches type string. But as soon as you turn this on, it's going to be a problem because the compiler identifies that X is a number while the print method is expecting a string. And this is the error we get. Argument of type number or undefined is not assignable to parameter type string. Again, you can tell how all these flags are giving you answers sooner rather than later, increasing your productivity. So you're not spending time downstream trying to figure out what's going wrong. Next up, we have strict DOM local ref types. This is about, if you look at the code here, we have an input on the left side, and we have a reference to the input by using the hash tag input. And then on keyapp.enter, we call the change value and we'll pass in the input to change value. And we look at the signature of change value, it's expecting a string. So without this flag on, this works fine until you do something in the function that expected this to be a string and turns out not to be. And then again, you have to wait until you're running the application to figure out that something is wrong. We wanna find problems as soon as possible. So by turning this on, the compiler, Angular compiler specifically, is going to tell us that the type HTML input element is not assignable to the parameter of type string. Next up, strict output event. This is about when we're using outputs and components, we can type them. So if we look at the child component, in this case, we've added an output called move. And that produces an event of type X, of an object with X and Y of type number. And then in the template, when the move event happens, we are passing the event down to move square. And if you look at move square is the signature is a variable called location of type with an object with the property X. It doesn't have Y in it. Again, we can see there's a mismatch between the move square function and the output. Without this flag on, everything is fine and dandy. But the thing, we might be using the values as in an unexpected way in the function because the types are not correct. So if you look at the error produce, we get type string is not assignable to type square. Then next up, strict DOM event. This one is a little bit similar to the previous one, but it's actually using the DOM API, so the events from the DOM rather than the events rather than outputs we write for ourselves. So it's checking that in this case the key I don't remember if it's key event or keyboard event is used correctly. Again, the function signature here is expecting a string, and that's not what we're passing in. So without this on, everything is good. And as soon as we turn it on, we get that type of keyboard event is not assignable to type string. And last, we have strict literal types. This one is basically about the compiler inferring the correct type from literals in the template. So in this case, I've just added some random literals to kind of show how the compiler will do. So the first one is just the string. We're not doing anything specific with it. The next one, we're doing an if. We're passing in an object with XY as numbers. We are assigning it to a template variable location, and then we are printing the location. We are displaying the location. And then the question will be, what is the type of location? Before, if you don't have this flag turned on, location is going to have type any. But as soon as we turn this on, the compiler is actually going to infer the type of location based on the literal. Same goes for ngFor. We have an array of XY objects, and without this flag on, this becomes an array of any, and everything works fine. We do location.z, no problem. But as we can see, z is not part property in the provided objects. So the compiler is going to infer that this is an array of XY objects, and is going to show an error saying that z is not available on location. Let's see. All right. There is one more flag that I omitted here, which is strict generic reference type, something like that. I didn't find the suitable example, so I just skip over it. In practice, I haven't come across it either, but it's good to know about it. All right. So now that we've gone through the theory, I'm going to quickly open up VS Code and go about fixing these issues. So bear with me. So right now, everything is compiling fine, no errors. So if I kill that, go to the TS configuration, turn strict on. So if you've done this on a reasonable application, on a reasonable big application, then you get a nightmare, because I did this on a project and suddenly I had hundreds of errors, and that can really be off-putting to be like, you know what, I'll do that later. I got time. But I've found that if you take incremental approach to fixing the errors, you get closer to having a project with the strict flags turned on. And in this case, if we run this with the strict on, do ng-serve, any moment now. Suddenly, everything is lighting up. Like so, this is a pretty small application, so I could probably fix this all at once, and I'll do that. But I'm just giving you a solution to if you suddenly get overwhelmed with all the errors and be like, you can't even scroll because you've exhausted the amount of buffer you have. You just instead you can actually keep it on, turn add the flags I've gone through, and then flip them on one by one, and then fix the errors as you go. And if you are working on a very, very large application, you could basically, as part of normal development, say every time somebody pushes a feature to the source control, you turn on the flags, get them to fix anything they can fix as part of that limited scope, and then turn it off again, and then send that in. And then over time, you're gonna get closer to the ideal situation. So in this case, I'm just gonna see, I leave strict true on, and then I'm just gonna quickly go through the code. So no implicit any. It's saying this is missing the type, so I'm expecting it to be a number. And then I'm getting an error because of initialization. So I'm like, okay, I give it a default of 0. It's just TS links because I have a rule saying if I don't want, if it can infer it, I'm gonna leave it out. It's just my personal preferences. So in this case, types you can infer what the type is from the value. And then here on the right side is telling me that this is a string, so I'm just gonna change this to a number. Everything is fine and dandy. And then we're going to visit this. Example that show up. So in this case, just to revert back to the case we had. So in this case, we have an old school function here. It's not an arrow function, so this is not scoped to the class. And then we're referring this to title inside the return here, and this is going to be undefined. So you're going to get a runtime error saying that you're trying to access title on undefined. So in this case, I'm thinking if I turn this to an arrow function, everything's fine. Right. And then we go to bind. In this case, again, these are strings, it's a splitting number, so I just make those numbers. And then we got strict null checks. In this case, we have an optional right, so this can be undefined. I'm going to use the new fancy knowledge coalescing operator. I'm going to say if the left side is null or undefined, to 0. Everything works fine there. And we go to strict property initialization, default value, for that to 0. Everything's good. And then we go to child component. This is complaining that this has no initializer and is not defined, is not assigned in the constructor. So in this case, I could basically decide that this can never be null, and give it, I don't remember the official name of that operator, or I can have a default value provided here. Good. And then let's go down and see what's remaining. We got the code wrapper, which is, and it's complaining that it has no initializer, so just give it string. And then I got we got the strict function before I go to the bonus. Strict function. So this is the custom validator that's complaining here. So if I change this to an abstract control, error goes away, because now this becomes contravariant, because we were just passing the right type as expected. If there was a super type to abstract control, that would have worked fine. And then, as a bonus, when I was preparing this this application for the presentation, I used the NGX highlight to highlight the code I was showing, and I got some errors when I'm trying to import some language files that are needed, and I tried to install the type package for highlight, but that didn't help. And in this case, I'm pretty sure you've had similar cases. The way to fix this usually, since this works fine at runtime, this is a type issue. You just create a typings.d.ts file in the source folder. And then I just declare the paths I'm importing as modules. And then finally, as we can see on the terminal, everything's good. Successful build. All right. So that was me. I hope this showed you that even though when turning the strict flags on might seem like a scary thing, it's very achievable, and one should strive to have the stricter settings on, because it makes you a productive developer. Thank you very much.
Thank you very much. Thank you for paying attention to us. Now we have our speakers, our awesome speakers, Manfred and Fabriasi with us. Now it's time for questions. So I'm going to start with Manfred. A few questions for you. I'll start from the first one. Someone asked that, I might be wrong, just wanted to understand how this concept is different from dynamically loading an Angular element on demand. I don't exactly remember when he or she asked this question, but I guess it's related to the first part of your presentation.
Yeah, I can imagine. I think it refers to lazy loading IB-based components.
Yes.
So the thing is, when you nowadays have a web component, of course, you can lazy load it. It looks similar to this. But the thing is, when you compile an Angular component as a standalone component, some pieces of Angular will stick in your bundle. And of course, this makes the bundle bigger. So loading web components is more about loading external compiled stuff. And doing this is more about traditional lazy loading, where really just the code for your Angular component comes into your system.
Okay, perfect. I hope that you got your answer. So another question is that we have possibility to load a module lazily via routes. So obviously we had that previously. So, and now we can lazy load components. From your experience, in what cases would you lazy load components?
So for the most cases, I would stick with the current strategy with loading modules by using the browser, because it is a no-brainer and it's really effective. On the other side, loading components on themselves in a lazy way has several advantages. Think about white labeling solutions, where you need to load specific components based on the current customer or based on the current tenant in a cloud-based solution. In this case, this could come very in handy. And of course, the Angular team is investigating ways for partial hydration. And that means perhaps in a future version of Angular, we will see, it's all about speculation, we will get this more or less for free, this lazy loading on the component level, where you just start with a static page and then get the rest. There are already prototypes, but it is somehow music of tomorrow or music of the day after tomorrow. So I think in long term, that could be something.
Okay, great. So another question is that with lazy loading components, will it be possible on website load to first load the content component with the main router outlet, and then after that load the header, footer, and etc.?
Yeah, it would be possible. So if you want to do this, you can do it really by combining those two levels. First of all, loading something with the router, and then within this page, loading stuff on demand, header, router, header, footer, or something like this.
Great. So a question for you, Fabrice, actually. From your experience, is there one of the mentioned rules that bring a quicker win than the others, so that they know what rule they can activate first?
I would say that the strict null one brings wins in the form that you will discover bugs that you wouldn't that you do otherwise miss. So other ones like strict initializations, all of them kind of make you discover bugs, but the null one is a very subtle type of bugs, which you usually miss when you're scanning through the code. But it also turns out to be one of the challenging one, because usually I think it's attributed to the style of coding you're used to. So you tend to have more of those places to fix, which way you'll be like, okay, if I can do it right now, the priorities are not aligned, can I do it incremental? Can I turn on the other ones, the ones that are easier to kind of just get it over with, and then slowly, as I said, one strategy is just either feature-wise or as you are getting in PRs, you make sure there's no PR landing without having first gone through the flags and turning them on.
Great. So I don't see any other question from you. If you have anything to add, maybe you can start, Manfred, and also the second one, maybe Fabrice, to tell our audiences right now, please.
Yeah, I don't know. I think the most important stuff here when it comes to these new features is to see we are currently talking about private APIs. And so it will take some time until we have a solid solution for the public ones. I think it will not happen before fall.
Okay, good. Fabrice, do you have anything you want to add?
Well, nothing specific. It's more if somebody is struggling with this stuff, I'm more than happy to help. So just hit me up on Twitter. And yeah.
Thank you very much. So on behalf of all GDGs in Norway and Angular meetups, I'd like to thank all of our speakers, awesome speakers, and all of you who are watching us right now. And I just want to let you know that we recorded this video and it will be available on GDG Bergen channel. So you can watch it anytime. You can come back to it anytime. So thank you very much again and hope to see you again. Have a good evening or good day.
Thank you. Thanks for having us.
Bye.
Bye.